Guys, I hope you all are doing well. So today our topic is, as it is seen here, congruence of triangles, right? So can you tell me what do you mean by congruent triangles? Any idea? Congruent triangles, okay, you will be doing or have already done at school. So what does it, okay, signify? So I'm going to explain you exactly what congruent triangles are and also certain shortcuts, okay, with the help of which we will be able to prove the congruency of triangles. Well, you will understand what congruency of triangles after you will have understood the meaning of congruent triangles, correct? So let's go ahead. So for example, we have triangle ABC and triangle DEF, all right? So these are the two triangles drawn over here. Now we can see that they look, okay, exactly like each other, okay, but seeing, okay, always doesn't help. We have to have a certain concrete evidence, correct? So we know that congruent triangles, okay, are exactly, okay, duplicate in terms of shapes and sizes, okay, as in the sides, okay, of theirs must match, okay, like it is matching over here. AB equals to DE, AC equals to DF, and okay, we have one angle given over here equals to D. All right. So in congruent triangles, we will have 6 elements matching with each other. All right. Means this angle is matching with this. AB just now is being shown equal to DE and AC equals to DF. All right. What about the rest of the things? Two angles and this side. Okay. So when we will have proved the congruency, okay, of these two triangles, we will conveniently say that BC is also equal to EF and angle B is equal to angle E and angle C is equal to angle F. So this is all about congruency. Correct, guys? Okay. So now I'm going to take you to the shortcuts, because every time you don't have to, okay, overlap this, okay, or pick this up and try and find out. Okay. So that is cumbersome and it's not advisable and nobody does that. Okay, guys. So let's go ahead with the criteria. Okay. So the first criteria that we have before us is SAS, as in side, angle and side. Okay. So this means that if two sides and included angle of a triangle, which means this side and included angle, okay, of a triangle are equal to the two sides and an included angle of the other, then the triangles are congruent. All right. So this is what they are trying to say. Now I would like to just say it because this is taught in 7th, 8th, 9th level. So as a result, we are not getting into where this, okay, has generated from. So we'll take examples to prove, okay, how, okay, we prove the congruence of triangles, okay, using 4 kinds of criteria. All right. So the first one is SAS. So we have to take, okay, triangle ABC to consider, okay, congruent to DEF. As a result, we have to have, okay, 3 statements supporting, okay, towards congruency with reasons. Guys, you have to give the reasons. Without reasons, it will not, baat nahi banega, so you will not be able to do it. So we have AB equals to DE, AB equals to DE and AC equals to DF and angle A equals to angle D. Now what do you mean by included angle? okay, like it has been mentioned over here, included angle means if you're considering these two sides, in between these two sides this has to be placed, okay, this two sides and here. If you could have taken anywhere here, okay, that wouldn't have worked. Got it? So this is the whole thing that you have to keep in mind, that whenever you're taking two sides, okay, the angle between these two sides will have to be equal to enable congruency for these two. All right. Now, having proved the congruency by merely having three statements, valid statements with reasons, we are able to get hold of so many more things, like what? Here, three elements are known to us to be equal. We also get that B becomes equals to E and C becomes equals to F and BC equals to EF. Okay, so to that we call it as CPCT. Okay, this is on the basis of, okay, CPCT that we are able to prove it. Okay guys, so corresponding part, okay, of congruent triangles. So which means angle B will be equal to angle E, angle C will be equal to angle F, all right, these two, and BC will be equal to EF. Now, okay, you may think, why should BC be equal to EF, and why B will be equal to E and C equals to F? Okay, there can be a question mark that B can be equal to F also, isn't it? So we have a reason to be saying so. B will be equal to E. Why? Because the side looking at, okay, the side AC looking at this angle, okay, and DE, DF looking at this angle, okay, ought to be equal, as they are equal to each other. I repeat, since AC is equal to DF, okay, so the angle opposite to these two equal sides have to be corresponding, have to be equal, okay. The same thing happens here, since AB is equal to DE and this side is looking at C and this side is looking at F, they must match with each other. Alright guys, so how many have we got? Three elements they have given, this side and this angle, this side and this angle. Am I right? Okay, what they had not given, that also we have been able to find. Correct? Got it? So this is, okay, all we have for this SAS criteria, and we'll go now to the second criteria. Alright guys, the second criteria, AAS criteria, what we find is that there are two triangles given, okay, and we have to prove their congruency, okay, if two angles, can you see it, two angles and included side of one triangle are equal to two angles and included side of the other triangle. All right, so here they have given A equals to D and B equals to E, and they have given this side BC is equal to EF. All right, now you must be wondering that can we call this an included side? It is not included with the angles, am I right? Means it had to be supposedly AB equals to DE to, okay, call it included between the two angles, right? So BC is in any ways not seeming to be included, okay, between the referred angles, angle A and B. So logically AB should have been equal to DE to enable us to prove the congruency of the two. Are you getting my point? If they're talking about included side has to be between the two angles, okay, in this case as well as in this case, which means AB and DE. So this is not very complicated. Once you understand, it becomes very easy. So we have to do something, okay, to be able to make this side included. Now by angle sum property, angle A plus angle B plus angle C, okay, equals to 180. The same thing here also, D plus E plus F is also equal to 180. Am I right? Since A is equal to D and B is equal to E, which means C2 is equal to F. Okay, isn't it? So this exactly we have written. So we had to do a little bit of working to make this, okay, tailored to our criteria. All right. So we can also write AAS. We can also write ASA also. Okay. And I'll let you know. So these are the two things, okay, that may confuse some, okay, children. So let's go for it and I'll explain you further about them. So A plus B plus C is equal to D plus E plus F. Correct? A plus B plus C. Okay, as per the angle sum property. When A is equal to D and B is equal to E, which is given, shouldn't C be equal to F? Alright? So which is what we have found out here. My C is equal to my F here, which means suddenly BC seems to be welcoming and it looks like it's included. BC and EF are included sides. Got it? Now we can write the structure of this. Remember, this has to have a head. Remember, whenever you're writing congruency, okay, you have to have a certain structure that you need to follow. I'll call this a head, this the body, and this the foot. Okay, so conform to these, okay, rules. It is always better to be systematic. So in my first case, I have B equals to E given. Reason is given. This is my statement. Okay, A equals to D and what? Okay, but we reject A and D. Okay, since we have found this, C equals to F. So we write C equals to F instead of writing A equals to D. Got it? So, and BC, okay, is equal to EF, which is given, and it is also the included side. You can write over there, included sides, both of them, okay. So, between B and C, so by angle, okay, side, congruency rule, the foot of it, the conclusive part of it, and finally we declare that triangle ABC is congruent to triangle DEF. Alright guys, and once again by CPCT we are given this equals to this equals to this, and this is equal to this. What about this and this? Okay, and this. Okay, so they too also should be corresponding to each other. And in what way? Let's find out. C is equal to F. We have proved just now. Since C is looking at AB and F is looking at DE, they must match with each other. So we write AB equals to DE. Since A is equal to D and A looks at BC, okay, so we have BC equals to EF, which is why they have given them to be equal. Alright. Now E and B, okay, are equal. So it looks at AC and this looks at DF. So AC will be equal to, okay, DF. Alright. So we call it corresponding parts of congruent triangles. Okay. So now because the side is in the middle and two angles are over here, so we can say this, okay, we can say this ASA conveniently. But we also approve this Y. Okay, so we go for this because automatically the third angle must find its place, okay, and give in any ways a side that is included. Okay, for example, in this case also what we found that they had given angle A equals to angle B, A equals to angle D, sorry, okay, and B equals to E, and they hadn't given this side. But did we not prove still? Because we found that C was equal to F, so automatically any side that they give, we'll find them, okay, being included side. Alright guys, so this you have to keep in mind. Okay, this is, you know, quite probable as much as this one is. So here we took, you know, a few steps to include this. But even if you would have barged and gone for AAS, you would not have been wrong, because indirectly, okay, we know that the third angle 2 would be corresponding to the third angle of the other triangle. Correct guys? So keep that in mind. Both of them are eligible to prove the congruency. Alright guys? So next we go to the third one. The third one is the easiest of all the four. The three sides of one triangle, say three sides of one triangle matches with the three sides of another. So this is, okay, eligible for being congruent to each other, okay. So all these sides, say AB equals to DE, AC equals to DF, and BC equals to EF. So this is sufficient to know that these two are, okay, congruent to each other. So in given, as we have triangle ABC and DEF, we have AB equals to DE, BC equals to EF, AC equals to DF. Alright, so BC equals to EF and AC equals to DF, which is here. Alright, now proof. Now by this time, now you must be knowing how to write, okay. It's very important that you should know how to write, present your work, and for that given. And what is my RTP that is required to prove? That also you have to write that triangle ABC is congruent to triangle DEF, guys, okay. So then comes the step of proof, and that brings in three statements with, okay, the reason why you claim them to be equal. AB equals to DE because it's given, BC equals to EF, okay, as it is laid down for us, okay, and AC equals to DF, right. Therefore by SSS congruency rule, okay, ABC is congruent to triangle DEF, and by CPCT we know that since this is equal to this, which means this must be equal to this. Alright guys, so and this is equal to this, so this side is looking at A, okay, so we call this as, okay, equal to each other, and obviously this remains. So because AC is equal to DF, we know that, okay, this angle is equal to this angle. Alright, so as simple as that. But guys, I can forewarn you, okay, it won't be coming as simple as that. There may be combination of, okay, diagrams. Like for example, they can give you something like this and they'll ask you to prove the congruency of this and this, something like that. Okay, so in, okay, some exercises we are going to get into that. So just now you try and understand the different criteria you may, okay, chart out to be able to prove the congruencies. Okay, now last we have RHS, okay, which is also very interesting. In RHS criteria, what we have is there is mandatory to have, okay, a 90 degrees in the two angles, all right, triangles. So for example, ABC is a right angle, okay, and DEF2 is a right angle. So if we break it up, what they are giving is that in two right angle triangle, the hypotenuse, this is the hypotenuse is a side which is longest in a right angle triangle, guys. Why? Okay, because it is overlooking the largest angle. Okay, so the sizes of the sides depends on the angle it is overlooking. So this is 90 degrees, they can't be 90 degrees ever. Okay, so this is supposed to be the longest side of a right angle triangle, correct? So that is a different information. Over here we need any side, whether it is the altitude or the base. So you have to have one side matching with the other side, and hypotenuse equals to hypotenuse plus the third, okay, thing that is required to prove in terms of RHS is a right angle, okay, in both the triangles, correct? So the same thing given in triangle ABC and triangle DEF. ABC, angle B is equal to angle E, and AC is equal to DF, hypotenuse, and AB equals to DE. Alright, so we could have taken this side also, okay, to be eligible for this thing, but since they have given AB equals to DE, so we cannot reject that. That's also eligible, right? So you can accept this also if they give you the base equal to each other, right? So the similar way we write over here, angle B is equal to angle E, right angle, AC equals to DF, which is hypotenuse, and one side which is the altitude, which is also given. So therefore we are able to do it, okay, by RHS congruency rule. All right, so, and as we can see that after we will have proved the congruency by CPCT again, the rest of the things that we proved that, okay, AB is overlooking C and AB is equal to DE, so C must match with angle F. Okay, similarly we have this hypotenuse which is looking at 90 degrees, which is why they are equal. And since we have got two angles, obviously A is only left, so which will go to match with D. So over here there is something more that I would like to add in here. Guys, don't just feel that since there will be a right angle, okay, in the two triangles, that you will suppose that it has to be proved by RHS. Not really. Okay, supposing they had not mentioned that AC is equal to DF, okay, they are the hypotenuse. In that case, you cannot, okay, use a RHS rule, all right? So it would, supposing this was equal to this, and there is a 90 degrees here, so you would then call as side, angle, side, side, angle, side, all right? So do not make that mistake. So you have to be very cautious. So this was all, and I hope you people have understood. Okay, so in case there is any queries, do write to me in the comment section. So that is all. So bye bye, have a great time. Okay, so in case you've liked the video, do subscribe. It gives us a lot of motivation. Okay, so that's all. Thank you for watching. Bye bye.